Hey kids, this is our Ivy Pre-Cal summer packet review. This is the first couple of problems. I'm going to go through problems 1, 2, and part of 3 in this video. And remember, these are skills that we are trying to highlight as to the ones that are going to be the most useful to you going forward, and the ones that you want to make sure that you are fluent at so that they don't hold you up from accessing the new material. So these questions here in number 1 are really just to make sure that you know how to manipulate equations. The word solve here is a little bit of a misnomer because you're not solving for any value. You're just solving for a variable, which means you're getting one of the variables by itself. So here you have to isolate f. Here you have to isolate y. Here, right? You're trying to peel everybody off of that by using your inverse operations in the appropriate order, right? So I'm going to just do a couple of these. This is a linear function. It's a diagonal line because it's an x to the first and a y to the first. I want to get y by itself, and I want to try to do as much as I can, right, without correctly, right, without making a mistake, right? And I don't have to write everything out. I'm going to use the inverse operation to add 12, the inverse to a positive 12 to a positive 5x, and I'm going to divide everybody by a negative 4. There's nothing wrong with that answer, but you probably won't see it that way. That is, negative 12 divided by negative 4 is 3, and negative 5 divided by negative 4 is positive 5/4. You will most likely see this answer this way, right? So here I definitely can see my diagonal line with a slope of 5/4, which is greater than 1. So this is a relatively steep line, and my y-intercept is positive 3. Okay, so it's just a lot more visible in this format as to, I'm much more familiar with this. Okay. Here, this is from geometry, not that you have to remember, but this is the area of a trapezoid formula. We don't need to do much geometry at all in pre-cal, a little when we're doing trig and some triangle applications. But in calculus, you're going to have to learn something called the trapezoidal sum for estimating area under a curve. So you might have to isolate one of the variables in here because you might be given the area or something like that. So here I have to remember that I need to get rid of the multiplication. I don't want to distribute this value through here first because then I've given it twice and I don't want to put anything on B1. So I'm going to multiply both sides by the reciprocal. And since then there's nothing in front of the parentheses, I can drop them. And then I'm just going to do the inverse operation to positive B2 and make that negative B2. So remember, when I have fractions, this is just 2a over h minus B2. This is a perfectly acceptable version of the answer, but you should always take a moment and say, hey, if this was multiple choice, would I recognize if they got a common denominator and put it all on top of h? Here I need to solve for v, here I need to solve for t, and here I need to solve for c. Notice these two equations are exactly the same. I just needed you to get a different variable by itself. I want to demonstrate this one because one thing, whereas both of these versions are perfectly acceptable full credit answers to isolating b sub 1, I'm going to isolate c here and give you an unacceptable. Not that it's wrong, it's just you would lose partial credit or you would never see this answer in multiple choice. This whole grouping symbol is multiplying c, so I'm just going to divide v by it. So if I have v is equal to 1 minus t over n is equal to c, right? I just divided both sides by that thing. This is not a full credit answer because you're never allowed to have fractions within fractions. So I want to demonstrate getting rid of this miniature fraction. So the first thing I'm going to do is work with the denominator only and get a common denominator. So I'm going to multiply by n over n there. So I have c is equal to v divided by n minus t on top of n. And then I'm going to use the definition of division and say that if v is divided by that fraction, that's the same thing as multiplying v by the reciprocal of that fraction. And remember, this is over 1, so I have v times n over n minus t. All right, so I just wanted to show you, you'll have to deal with that in both D and F, dealing with not leaving a fraction within a fraction for your final answer. Again, you wouldn't lose all credit, but you would lose partial credit. And if this happens to be a multiple choice question, this red box would not be in the answer, right? Only the blue box would. All right, number 2 goes over some function notation. So let me just do some quick background on this, right? F of x is a diagonal line. G of x is a parabola that opens up. H of x is an absolute value v that opens up. And k of x is a top arm of a sideways parabola, right? So I'm not going to do these ones because these are just plug and chug, right? You're given an input, what is the output? Given an input, what's the output? Given an input, what's the output? Given an input, what's the output? Right? I expect you to be able to do that fairly quickly. Plug and chug and evaluate. The only thing I want to say about D is that sometimes students confuse evaluating a square root and solving a quadratic equation. For example, this means putting in, for x, putting in 19 is the square root of 16. The square root of 16 is an integer, so you are expected to simplify to an integer. If that had been the square root of 15, you're supposed to leave it alone. Do not give me a calculator approximation. I just want the exact answer. But the square root of 16 is exactly an integer, and only one integer. It is not plus and minus 4. And that's because the square root function, right, when you put in 19, you get out only one value, that is 4. Students confuse that with, hey, if y is equal to x squared, what do you get when you're asked to solve that equation? Well, this is not a square root equation. This is a squared question. This is asking for the function x squared when y is equal to 16. How many x's reproduce that? Well, 4 squared is 16, but negative 4 squared is also 16. So solving a quadratic, you get 2 answers. X is equal to plus and minus 4. Right? Because you're giving a range and asking how many domain can give it. But when you're dealing with a square root function and you're giving an input, your range only has in order to be a function, you can only have one result, right? So think about it as evaluating a radical gives you one answer, solving a quadratic, a degree 2, gives you 2 answers. All right, let me erase that and get to the next pieces. And the next pieces are composition, right? You did composition in AAF. Here's composition of a number. If you're working inside out, I need you to tell me what f of 0 is. F of 0 is go to the function f, put 0 in for x, and you get negative 3. So you're going to replace that with negative 3, and then you're just going to do plug and chug, g of negative 3. Right? You're going to do the same thing with this. What is k of 4? You're going to put 4 up here, 4 minus 3 is 1. Square root of 1 is 1. So this is actually equal to h of 1. You're going to go up to the function h and put 1 into it and give me an output. Okay, so it's just like a pre-step, right? Instead of giving you a number, I give you function notation for a number, and you have to figure out what it is. These two, though, ask you to input all the range values from f into g. So here I have to say g of f of x is equal to 3 times x squared plus x minus 1. And then I have to input all of the answers, not just when f is 0, not just when k is 4. Into g, I have to put every answer for every f of x. How do I know what that is? Well, every x gets multiplied by -2 and subtracted by 3. Every x gets multiplied by -2 and then subtract 3. And then you need to clean this up. And let me tell you, the most common mistake here is simple elementary school order of operations. Some students distribute the 3 in first. You can't do that because we've agreed that squaring comes first. Then some students just square, and they say, oh, -2x squared is 4x squared and -3 squared is 9. No, honey, right? You have to square appropriately, and you get 4x squared plus 12x plus 9. Right? And then you have -2x minus 3 minus 1, and you need to clean that up by distributing the 3 and then combining like terms. And again, you can see all the answers to these online, but I wanted to make sure of those processes. Continuing with number 3, I'm actually going to do this screen backwards because the last ones here, M and N, are just plug and chug, right? Go to h and plug in a plus b. So h is over here. So I say absolute value of 5 times x plus 2, close absolute value, and in the parentheses, instead of x, I put a plus b. Clean it up a little, and you'll be done. Done. Okay, go to k, instead of x, put x squared. So these ones are plug and chug. These two here are a fancy way of asking you kind of sort of about transformations. You're taking all the range values from f and multiplying by 3. You're taking all the range values of g and moving down 4. So 3 times f of x is just going to be 3 times that. I had a linear function. Now instead of having a slope of -2, I have a slope of -6. Instead of having a y-intercept of -3, I have a y-intercept of -9. G of x is a parabola. I don't know exactly where its vertex is, but I know it has a y-intercept of -1. So guess what g of x minus 4 is? It is a new parabola, but the only difference from g is that its y-intercept is at -5. Everybody's been moved down 4. Now I'm going to erase that to get to the top 2 because they're the ones that are the most important on this slide. The inverse notation. Firstly, please don't confuse this inverse notation with this reciprocal notation, right? And I understand that because in real numbers, the multiplicative inverse of 3 is the same thing as the reciprocal of 3. That does not work in function land. The inverse of a function is switch the domain and range, or switch the independent variable with the dependent variable. So to do the algebra, you just need to take f, and remember this really means y, and switch x and y. And then you do the objective that was covered in question 1, right? Get y by itself. So you're going to do the inverse operation to minus -3. You're going to add 3. The inverse operation to multiplying by -2, and you're going to multiply by -1/2. So y is going to be equal to -1/2 x plus 3. Right? Add 3. Oops. Gotta have to divide by -3/2. My bad, right? Because I have plus 3, but I have to divide by -2. There's a plus 1 here, you're dividing by -2. So this is equal to the inverse of f. Now, for a linear function, the domain is equal to the range, right? A linear function has a domain and range of all real numbers. So switching domain and range can't really tell, but when you can tell it's a different graph by algebraically switching the x and y. Here's the graph of the inverse and the graph of the original. Looks like that, something like that. Ah, no, it doesn't. It has a negative slope, you silly woman. Sorry. That's not the problem. The problem is here. Students don't really think about domain and range of the original, right? But we taught you to do that in AAF. So the domain of a radical is x minus 3 can't be negative. So, right, you can't take the square root of a negative in real numbers, and we are graphing on real numbers. So you need to understand that the domain here is x is greater than or equal to 3. Think about why that would be true, right? When you put 3 in here, 3 minus 3 is 0, and the square root of 0 is 0. So the range is y is greater than or equal to 0. For the inverse, after I do the algebra, you need to make sure that the domain is not all real numbers. The new domain is the old range. And the new range is the old domain. Because when you do the algebra, you're going to say y is equal to the square root of x minus 3. Switch x and y, so you're going to get x is equal to the square root of y minus 3. Square both sides and add 3, and you're going to get y is equal to x squared plus 3. But x squared plus 3 has a domain of all real numbers, and that is not the domain of the inverse. Remember, this graph, the original graph, is the top arm of a sideways parabola. The inverse has a domain of x is greater than 0 and y is greater than or equal to positive 3. That graph looks like this. I'll put it actually up here. The right arm of this full parabola, right? So it is important to know the domain and range of the original when they are restricted, as opposed to a line. Who cares when the domain and range are both the same? Doesn't matter. But you are responsible for the domain and range of the original, and knowing that when you take the inverse, you switch them around. And again, you should remember something else from fun fact about inverses, right? They are symmetric across the line, y equals x. Factoring, my kids, never, ever, ever goes away. If you are not fluent in factoring, you will not fail. You will not have a sad life. You are not dumb. It just means that you have an obstacle to accessing higher level math and science. Factoring of all types is so foundational to everything, virtually everything you do going up, that it will just slow you down if you don't practice now and get fluent. So questions, this is an algebra 1, factoring of a quadratic, right? This quadratic has 2 factors, right? It is a quadratic, so it is not a coincidence that you have 2 factors, 2 factors, 2 factors. Right? So all of those should be quick. This one is a 3rd degree. When you have a higher order, I need to remind you, if I asked you to factor the number 12 and you told me 4 times 5, or I told you 4 times 5, you'd call me a liar, because 4 times 5 does not equal 12. If I asked you to factor 12 and I told you 10 plus 2, you wouldn't call me a liar. That's a true statement, but I didn't factor, because factor is a product. So when I ask you to factor 12 and you give me all the prime factors, 3 times 2 times 2, you know that's correct. You have factors, and when you actually multiply the factors, you do indeed get equality. So when I tell you that, for instance, this quadratic, I can pull a 6x out of both of those terms and get an x plus 3. There's 2 factors multiplied together, and when you distribute it, you get 6x squared plus 18x. But if I asked you to factor 12,478, you don't know the factors of that. You have to start dividing. So anytime you have a higher order polynomial, you have to start dividing. But before you start dividing, think of any shortcuts. Hey, is there any common factors in this? I can pull out a 3x. And then I have 1, 2, 3, right? Because that's x plus 2 times x plus 2. 3 factors. That's why there's a 3 there. Uh-oh, a cubic, and there's nothing in common I can pull out. So I have to divide, or this is a special case of cubics where, and if you don't remember this trick, please don't stress about this. It doesn't come up that often. What makes x cubed a perfect cube is x. What makes 8 a perfect cube is 2. Square the x, multiply the 2 and the x, square the 2. Because this is a plus, this is a minus and a plus. This factor is prime, meaning it does not factor into nice or even real factors, so you may leave it like that. Again, don't stress about if you don't remember this pattern. There are some things you better be able to do quickly. All of these, algebra 1, right? This one, this one, this one, and these 2 should take you a little bit longer, but not too much. If you have to split the middle term or use the quadratic formula, that's fine for now, but you're going to be in trouble as you go on, because you're going to have to do harder math that's going to take you longer, and this is going to be built into it, and if this piece takes you long, you're just not going to finish. So please, Khan Academy this stuff, right? Factoring. Don't stress about the cubes, right? Certainly look in case you can pull out a common factor, yes. But if you can't, don't stress about long division for doing things quickly, or even that cubic trick. Now, here are some more ones that should be, this one should be quick. Difference of 2 perfect squares. Right, that should be quick. This one is also the difference of 2 perfect squares, but it's kind of tricky. See what it did there, right? 9x squared times 9x squared is 81x to the 4th. Unfortunately, you're not done with this problem. This factor is prime, but this again is the difference of 2 perfect squares. So my final breakdown is 9x squared plus 1 That's what I get at the end. This one is a regular, right? It's an algebra 1 quadratic, just with a leading coefficient that isn't 1. That takes you a little bit longer than if the leading coefficient was 1, but not that much longer. So I want to focus on K and N now. So you look at K and your mind might go a little wonky, right? You're like, oh, what the heck? Too many things going on. Well, the first thing I want to do is say, is anything in common? When I see so many things jumbled up, hey, you know what? Isn't, right? And it's 1, 2, 3 terms, right? And that these both are squared. That's a square there. So let's see what I can do. This is kind of sort of quadratic-ish, right? So, whoops, I'm sorry. I was thinking of the one above that. Up here. This one is a quadratic, even though it has a y in it. I'm good and quick at this, but only because I've done this a gazillion times. Right? I broke down the coefficient of the first term. I broke down the coefficient of the last term, and I did a couple of trial and errors until I came up with the middle term. Okay? This one, again, there's so much crap going on, I'm going to look to see if I can pull out something in common. And isn't it true that 2 and y squared is common to everybody? Now, this is like that problem. Right? It is a little bit more complicated. It takes me a little bit more time. But my 2y squared stays out in front, and then I'm going to break down this quadratic into 2 factors. And I broke up 12, a couple tries, and I got 3x and 4x. Broke up 6y squared as 3y and 2y. And when I checked those, I'm really just good at guessing and checking, right? Once I see my quadratic pattern, right? I get -9 and -8, which is -17. This one has 1, 2, 3, 4 terms. We covered this in first semester of, probably the last unit maybe, of first semester in AAF. This is when you have 4 terms, the technique that you're going to default to is factoring by grouping. Right? And there's a number of different ways that you can try it, but you're going to try until you get matching groups in the middle. So I used the associative property, and I grouped these two, and I pulled a 4x squared out front. Right? Double check and make sure that's equal to 4x cubed plus 12x squared. Right? I'm not changing anything. Now, I am going to factor a -9 out of the next group. If I factor a -9, don't I also get x plus 3? Factor a -9 out. Factor a -9, that gives me a +1, and -9 out of -27 is +3. So now, and again, double check to make sure that I didn't change anything. There's -9x and there's -27. Now I want you to look at these two groups. They are the same. And I want you to take this group and pull it out front of the big group. And what's left? If you pull this purple group out, all you have is 4x squared. And if you pull this purple group out front, all you have is negative 9 left. And again, distribute this back, this whole group to 4x squared, and you get 4x squared plus x minus 3. The whole group to negative 9, and you get negative 9 times x plus 3. Didn't change it. Now you have to keep going, because while the first factor, x plus 3, is prime, the second one is not. It's the difference of two perfect squares. Woot woot! Factoring by grouping does come up. It doesn't come up nearly as often as the difference of two perfect squares, perfect square trinomials, pulling out a common factor, right, and regular algebra 1 quadratics. That's your main focus. That cubic trick and the factoring by grouping are down on your worry list. Yes, they are techniques you need to know, but more importantly is all the rest of the factoring needs to be very, very fluent, and you only get that way by practicing. All right, that's the end of our first video.